32 channel system with bands with a band covering the range of about 800 to 1600 megahertz in frequency. And we have a total of 460 integrations in this pseudo observation, where each observation has 60-second time integrations. And when we actually ran the observation, we specified we wanted to load the data in tiles of size 48, which means we want to load things in blocks of 48 time samples. And so in our range along the y-axis, we actually have 48 time samples, and we're going to see that we actually have 10 separate samples if we wanted to iterate all the way from sample number 1 here. We can move our little range controller here allows us to iterate smoothly from one sample to the next. We can iterate all through if we wanted to. Go back to this one. As we're going to go back to the first data set, first let's look at the color bar range on either side. If we now go back to our first visibility sample, you'll see that the color bars change their scale each time, and that can make it hard for us to really trace out are there systematic or smooth variations going from one time block to the next. However, what we can do is we can actually, there's an option to lock the color scales, and at present we do it separately for the real color bar on the left and the imaginary color bar on the right. When we iterate to the next visibility and the succeeding ones now, we're going to see that the intensities don't change. That should allow us to see, for example, that this particular minimum in the visibility, when we step into the next time block, should actually appear down here. And this guy here, for example, this minimum should also extend smoothly into the next time block. And here this maxima should appear in the next time block. So let's see if that's true. And indeed it is. So here we had 2 incoming minima where we expected, and here we had incoming maxima. Now, one thing we can do, just as we were showing in our n-dimensional visualization, is that anywhere you wanted one of these 2-dimensional plots, you can always request a cross-section for whatever needs you happen to want at that time. And if you click with your middle mouse, okay, it's interesting from a previous test run I did. When we deal with complex value data, we actually have an option in the system where we can either have the cross-section run continuously from the real data through to the imaginary data, or if we want, we can show the both cross-sections at once. Now, in the case where we're having real and imaginary data, it's probably okay to be showing both cross-sections at once, but I'm going to show in a minute or two when it becomes more confusing. So again, here we have the X cross-section, and this is the scale for both the, unfortunately we don't have any more scales allowable to us here, so this scale on the right shows the essentially the variation scale for both the imaginary cross-section and the real cross-section. And of course in this section, in this case the y-axis is the kind of data that's being shown here is always the same kind of data, so you don't get a big discontinuity here where we're going from real to imaginary. Now let's remove the cross-section. Where are we? Delete cross-section. Okay, now as I said, by default, when we first start up one of these displays, we show the real data as a function of frequency and time here, and the imaginary data as a function of frequency and time here. But if we want to convert and look at amplitude and phase, we can do that. There's an option to show data as amplitude phase, and indeed then the scale looks quite different. Now what happens, of course, now is if I do request my cross-section, I get a big discontinuity because this part of the cross-section are doing amplitude displays, and then over here we're doing a phase displays, and they don't really relate to each other at all. So in this sort of case, it's much more useful to, say, select that I want an amplitude section, and that'll get a proper amplitude-related scale on the right, or I want to look at a phase cross-section. Then we'll get our phase scale on the right. Phase is always plotted in terms of radians, and so we go from -3 to about +3 radians and a bit. And indeed, we can see that the phase is wrapping when we're getting these discontinuous jumps. We can do things like we did before, show data with logarithmic scale, which we don't want to do. Again, with visibility data, it's rather common that we might want to change the selected vels. And the reason for that is, of course, in a visibility observation, you're going to get parallel hand signals, either XX or and X and YY, or RR and LL, which contribute most to the total intensity scale. And of course, you can get cross hands, which essentially represent polarized data. Now, in the observation I was simulating here, I don't think I simulated any polarization effects. So if we change the selected vels, and we drag our little vel selector in, when we actually select a result here, and I go to one of the cross hands in the middle here, I think we're going to get a value pretty well of 0 everywhere. But yeah, okay, indeed. Let's see, what do we have here? 0 and 0. Yeah. So I'm not quite sure why I'm getting our 0 value should be in the middle there. I'm not quite sure why that is in this case. Anyway, it's probably confused by these. I've left this cross section running. Delete that. Anyway, this isn't terribly exciting. It's uniform. Let's go back and get our vel with the change our selected vel back to something which looks more useful, our first value. Let's get rid of that. Whoops. Don't want to do something like that. Let's just get rid of him. We can go back to our change to amplitude and display. To change to show real and imaginary. I think that's pretty well it. There's not... basically, you just have to remember that things are different on the left and right hand side of the screen. You can do your usual things like printing out a copy of your plot, or you can save in PNG format, etc. Again, you can show things in grayscale if you like. In this particular case, it's not terribly exciting, but if you had weak visibilities near the noise level, for example, this sort of display might be more useful to you. And I think that's actually probably a good stopping point.